any idea how you go about this?
So if we want the gradient, do we do m equals y2 minus y1 over x2 minus x1?
Yep. Excuse me.
So it would be 4 minus 1. Or would it be 1
yeah.
minus 4?
4 minus 1. They'll both work out.
Okay.
So long as you're consistent with the bottom.
But how do you work out the gradient of the tangent t? Because that's the first question.
Oh, tangent t. Let's see, that goes through 3, 5 and 1, 1.
Oh, so you use those two coordinates?
Yeah.
So it'd be 3 minus 1. Oh no, 5 minus 1.
Yeah.
Over 1... No, 3 minus 5.
X coordinate of A?
Oh, 3 minus 1, sorry.
Yeah.
Which is 4 over 2, which is 2.
Well done. Okay. How about, let's see, part 1.
So it'd be 4 minus 1 over 2 minus 1.
Yeah.
Which is 3 over 1, which is 3.
So that is 3. And they're then getting a different point on the chord, y equals x squared. And you can use a calculator. What would be this part 4? So 1.01 and 1.10 squared is the other number.
So would you do 1.0201 squared?
No, that's just the square of... you could just put it all in the calculator. You don't need to bother with the square malarkey.
Okay. Wait, so are we working out the gradient still?
Yep.
So would you do 1.0201 minus 1?
Yeah.
Over 1.01 minus 1.
Yep.
Which is 2.01.
Well done. 2.01. Okay, so what happened? What happened here? When we did AP, we got a gradient of 3. When we do all of these, we'll get like 2.5, 2.1. It's 2.01, and if it's a perfect tangent, it's exactly a gradient of 2.
Yeah.
You see this curve, y equals x squared. Line is going down on the left, negative tangent. Line is going up on the right, negative gradient, positive gradient on the right. Yeah. And so the gradient is always changing. And so all you can do is find the gradient of the curve at a single point. Yeah. One way to do that would be to pick a chord, so 2 points, and that would give us an estimate of the gradient. An even better one would be a tangent at exactly that point and get the gradient of that tangent.
Yeah.
Lots of fun. Let's see. Finding the derivative. Let's see. It's pretty good. Now let's do part 5. The 1 plus h squared.
Yeah.
I'm just gonna get more room. So we have x and x squared. 1 plus h. Am I getting ahead of myself? I might be. This might be year 2. Let me just... What is this? The point A... with this lies on this curve. At point A, the curve has gradient g. Show that the limit of 8 plus h. I don't know. Find the derivative. So that's it algebraically. I don't know how to do it with part of it. The f4. Okay. So for this one, we can use some numbers.
Yeah.
One point is 416. Another point is 4 plus h. So 4 plus a little tiny bit extra. And the other part will be 4 plus h squared.
Yeah.
So it's like, y equals x squared. So I'll just write the other one as 4 squared. Okay. Gradient. Okay, gradient for this. How do you get it?
Okay. Could you simplify the one on the right, or is that not possible?
Yep.
Could you expand the brackets of 4 plus h?
Yep.
2 brackets.
Yep.
So it'd be 16 plus 8h plus h squared.
Yeah.
And then could you multiply it by 4 plus h, or would that not work?
That would be cubed. We only need squared.
Okay.
And so sub them in.
Okay. So it'd be 4 plus h. Wait, no. Wait, yeah. 4 plus h squared plus 8h plus 16.
So that is y2 h squared plus 8h plus 16, and then take away y1, which is 16.
How come you don't use 4 plus h at the start of that?
That's x.
Okay. And then for the other one, would it just be 4 plus h? And then for x2, it's 4 plus h.
Take away.
And then minus 4, and then 4 squared.
X1 is 4.
Oh, it's 16. Is it?
No. X1 is just 4. So it's 4, 16.
Yeah.
And then the other one was this one.
So 4 plus, so it'd be h squared plus 16h plus 6 plus 8h plus 16.
So h squared plus 8h, and then plus 16 minus 16?
Plus 16.
Okay, what is plus 16 minus 16?
0.
Yep. And what goes on the bottom?
Would it be 0?
4 plus h
Oh no,
minus 4.
4 plus h minus 4.
Plus 4, take away 4.
0.
And you also have a plus h.
So just be h.
Yep. And simplify. You can try factorizing the top.
So could you cancel out the h squared plus 8h?
Yeah, you could divide both of them by h. And so what remains?
So when you divide by h on both sides, would it just give? Does that get rid of all the h's in the equation?
It gets rid of one h from each term on the top. And so
You get h squared plus 8h plus 16.
No. H squared divided by h?
You just get h, so it'd be h plus 8.
Yes, and that's what we were trying to show. 8 plus h, h plus 8. So this is just proving it. I'm not a big fan of this. Well, proof is proof, I suppose. But what's this all about? Prove from first principles. I don't want to spend a long time on this. But the big picture is, this time it's x cubed. So when you sub in x, in general you get x cubed.
Yeah.
That's x1, y1.
Yeah.
x1, y1. The way you prove it is you do a very small change in h. So h plus a little extra.
Yeah.
And that you get x plus h cubed. You would expand that out. What would you get? I don't know. X cubed plus 3x squared h plus 3xh squared plus h cubed. Is that it? So that's y2.
Yeah.
Take away y1 is x cubed. That's divided by x2. Take away x1. So what will be on the bottom after you do x plus h minus x? Yep, you have h on the bottom. Okay, on the top. On the top, let's see. On the top, everything's the same.
Yeah.
I think. Is that right?
No, you can cancel out the x's, can't you?
You're right, that's it. The x cubes cancel.
Yeah.
Okay, and then you can divide everything by h. So after you divide everything by h,
you'd get 3x squared plus 3x h plus h squared.
That's it. So 3x squared plus 3xh plus h squared. As h tends towards 0, so let's say h becomes 0, what are you left with? If you substitute 0 for h.
Wouldn't you just get h squared?
H becomes 0?
Oh, 3x squared plus just 3x squared.
3x squared. And there we have proven that the derivative of x cubed is 3x squared. So what's going on with all this? It's all a bit bonkers. I'll show you why. We proved it. Now we can just use it. Basically, the gradient of a curve is always changing.
Yeah.
And all you can do is get it at a point, and that's the same as the gradient of the tangent to that point. The gradient of a straight line is y2 minus y1 over x2 minus x1.
Yeah.
We did it in pure algebra, and what we found in pure algebra was the gradient of x cubed is always 3x squared.
Yeah.
What that means is if you want to find the gradient of any point on the line y equals x cubed, you have a formula, gradient function, called and it's 3x squared. So you can use that. So let's say on the coordinate when x is 2. Yeah.
Yeah.
Now, let's say x equals 5. When x is 5, what is the gradient?
Okay. So you want it like as in h minus, like
Instead of x, you have 5.
so it'd be 3 multiplied by 5 squared,
Yeah. What is that?
which is 75.
Well done. And so that there, instead of having to do y2 minus y1 over x2 minus x1, we have a formula that does it for us.
Yeah.
And let me just show you what it looks like. This was a cubic one.
Yeah.
And it would look something like that. So let's say when x is 5, which is like somewhere here, the gradient is 75, and so it's very steep. Now it's about to get a whole lot simpler.
Okay.
Prove these from first principles. I don't want to spend a lot of time on first principles. It takes a long time, isn't worth very many marks.
Yeah.
Let me see this one. First principles. Okay. In general, if you look at a pattern and you can prove it, you will notice that there are 2 steps. Step 1 is power times coefficient. Step 2 is subtract 1 from the power. So I'll write that down here and we'll use it to figure these out. Step 1 is power times coefficient. Step 2 is subtract 1 from the power.
When you say coefficient, what do you mean by the coefficient?
Number to the left of x.
Okay.
X to the 6 is the same as 1x to the 6.
Okay.
Okay, so part A. Derivative for A.
So would it just be 1 multiplied by 6 for the first step?
Yep.
1 multiplied by, so it'd be 6.
Yep.
Would it be 6x or just 6?
6x, and what's the
then
new?
To the power of 5.
Correct. And so if you wanted to find the gradient of y equals x to the 6, let's say when x is 2, you would just do 6 times 2 to the power of 5.
Yeah.
Part B.
It would be a half x
Mm-hmm.
to the power of minus a half.
Well done. Minus a half. And you can always use your calculator if you're not sure.
Yeah.
Part C.
Minus 2x to the power of minus 3. Or it's minus 3.
Yeah. How about D? Involves some work.
Okay. So would it be 6x cubed?
Hold on. What is x squared times x cubed the same as?
Oh, you do that part first.
Yeah.
So it'd be x to the power of 5.
Yeah, that'll make your life
So it'd
much
be
easier.
5x to the 4.
Yep. And part E.
Would it be x to the power of minus 4, or would it be minus
Correct.
5? Yeah. And it'd be minus 4x to the power of minus 5.
Well done. Very good. So we did fraction, we did negative, we did normal. Okay. This thing that we've been finding, it's got a few different names. If you have y equals, then it's called dy dx. That's like change in y over change in x.
Yeah.
Just gradient. Part A.
But we don't know what y is. So how do we do change in y over change in x?
If only I had just taught you how to find the gradient of function even when you don't have 2 coordinates. The general formula. Step 1, step 2.
Oh. So it'd be 21x to the power of minus 2.
Correct. Sorry, you cut out for a second. Did you say?
Then would you do 21x squared over 7x to the
No,
cube?
no. Finished. Full marks.
Oh, okay.
Part B.
Minus 2x to the power of minus a half.
Yep.
Minus 6x to the power of minus 3.
Mm-hmm.
So would you do 8 divided by 3 as well?
Yeah, I'd do the x's first.
So it'd be 6 x to the power of 6.
Yeah.
And then can you do 8 divided by 3?
Yeah. You can do 8 over 3.
It's reoccurring.
Okay. And so power times
7.
coefficient.
So it'd be 6 multiplied by that. So
Mm-hmm.
it'd be 16x to the power of to 5.
Well done. Any idea how you do E?
Okay. So you'd get 6x to the squared.
That is to the 3 over 2. Square root is the same as power of a half.
Okay. So it'd become 3 over 2, which is 9. So it'd be 9x, and then minus 1.
Not minus 1.
You wouldn't minus 1 from it?
Oh, sorry, you would, yeah.
Oh, it's a half.
Yes. And what is x to the half the same as?
0.5? Oh no, square root.
Yes, it is the square root of x. And so they gave us the question as a square root, so I'm just giving the answer back as a square root.
Yeah.
But yeah. Okay, I think you're good. I think you are good. Okay, exam time. Let's do it. Any idea how we do this one? Before we do that, hold on. They don't get easier, do they? Kind of. But no. Alright, let's try it.
Okay. Can you just substitute 2 in for x?
No, that will give you the y coordinate. We want the gradient.
So you'd use m equals y2 minus y1 over x2 over x1.
Let's see. No. You would, because this is a curve, and so you would use gradient function.
So we used what we used before.
Yep. And do you know what a different way of writing this one is? Y equals, instead of 5 over x to the 3, 5x to the power of.
But where did the x come from 5? Because there was never an x there.
Excuse me. I need to put a question before this. 5 over x cubed is the same as 5x to the minus 3. Those are the same thing.
Yeah.
And so that's what y equals. What is dy dx?
So it'd become minus 15x to the power of minus 4.
Well done. And we want the gradient at the point where x is 2.
Would you substitute 2 in for x? So it'd be... Would it be 2 to the power of 4 first, or 2 multiplied by minus 15?
It's all the same to a calculator. Although, Bidmus, you do power first.
Okay. I got minus 0.9375.
And press answer. And equals.
minus 15 over 16.
Yay, I like it. Minus 15 over 16. Much easier answer.
Yeah.
An exact one. And you see this x to the minus 4?
Yeah.
If you were to put that back into, make it look more like the question, what would it look like?
What do you mean? Like when you multiply the power by the coefficient?
What I'm getting at, I need to put a question before this. It would be minus 15 instead of x to the minus 4 over x to the plus 4.
Yeah.
So I'm just reversing this
Yeah.
thing there. So you could have put into your calculator minus 15 over 2 to the power 4 and you'd get the same answer.
Yeah.
Yeah, literally minus 15 over 16. Well done. Okay. They're getting weirder. How about this one?
Okay.
And actually, well, no, I'd better not show you how to cheat just yet. Okay, how about this one?
Okay. So is that the same as minus ax minus a half to the x to the power of minus a half?
Brilliant. Minus 8x to the minus a half. Square root is a half over minus. Yep.
So when you do the coefficient multiplied by the power, would that give a positive number?
Yep.
So it'd give 4x, and then a half to the power of a half.
That would be plus 1. Minus a half minus 1.
Minus 3 over 2.
Mm-hmm.
And then you substitute 16 in.
Yep.
I got 1 over 16.
Great. Looks good to me. And so the gradient of this curve, when the x-coordinate is 16, is 1 over 16.
Yeah.
There we go. Cheat day. Okay. Calculator. You see this d by dx? It's yellow over the thing, the integral symbol. So shift integral for d by dx.
Yeah.
5 over top right x to the power of 3, and press right until you get x equals, and it is x equals 2, so the gradient at that point.
Yeah.
And you should get minus 15 over 16 or minus 0.9375. Maybe that's a limitation, that it gives it to us as a decimal and not as an exact value.
Yeah.
You have to watch out for that. So this one, you want to try this one?
Okay.
Shift integral.
So it'd be minus 8 over. And then would it just be a half, x to the power of a half, or do you keep it as square root x?
You can do minus 8x to the minus a half if you want. I'm just doing it exactly as the question gave it.
At interval 16, which is 0.0625.
Okay, so that is the 1 over 16. Let me press answer. Yeah, so it doesn't give it, it gives it as a decimal, so that might be, let me try something. 0.0625. 0.0625 equals, okay, so you just have to type it in. But my guess is it won't, they'll find a way to thwart us, I'm sure.
Yeah.
They don't like us cheating. And, okay, they think they've thwarted me. They haven't quite, but we'll see. Okay, how do we do this?
Okay. So can you work out 2x to the 4 to be 2x cubed? like multiply 4 by the coefficient and then
Yeah,
take
yeah.
away 1 from
What
4.
would you get?
8x cubed.
Yep. Mm-hmm.
When it says x equals a is 27, like, what is x then? Because
That's,
like
that's
a
what
is 27.
that's what you have to solve.
Yeah.
So there's some x coordinate. When you sub it in, you get a gradient to 27.
So can we minus 27 on both sides?
Definitely not. So what you're aiming for is a equals.
So we can divide by 8 on both sides,
Correct.
which is 3.375.
Okay. 27 over 8 is fine by me.
Okay. And then you'd cube root both sides.
Well done.
Which is 3 over 2, or 1.5.
Well done. Find the value of a. So 3 over 2, good. 1.5, also good. Yes, so this time we had to work in reverse. There's a way it can be done in the calculator. I won't bother. Differentiate, sub in, make equation, solve equation. 3 over 2. Right. This one, let's try this. Two weird ones. Which is less weird of these two? I'm going to say the top one, believe it or not. How about this?
Okay. So is that a coordinate then? The equation, because there's a comma between them?
No,
0.
that's just extra information. Y is greater than or equal to 0.
Okay. So for minus 64x cubed squared, can we multiply 2 by minus 64?
That would get you the y coordinate. We want the gradient. So we first want y equals so that we can get dy dx equals.
So can we minus y cubed on both sides?
Yep, or you can add 64x squared on both sides.
Okay, which gives you y cubed equals 64x squared.
Yep.
And then can we square root both sides?
Cube root.
Cube root.
Yep.
But if you cube root, would that get rid of x on the right if you cube root?
No.
Okay. So it'd be y equals 4.
Yep.
4x.
4x. So it's like 4, the cube root of x squared.
Okay.
And any idea how you can write that in index form so it's easier to differentiate?
2 over 3.
Well done.
Yep.
Now you can do what you like.
And then you multiply that by 4. 2 over 3 by 4.
Yep.
Which is 8 over 3.
Yep.
X. And then you do 2 over 3 minus 1, which is minus a third.
Mm-hmm.
And then you can substitute 27 for x.
Yep.
which gives you a third.
Third? I thought it would be a nice answer. A
And
third?
then, no, not as the final answer.
Oh,
As
you.
in like x, as in like 27 to the power of
All right.
minus a third is a third.
Okay.
And then answer multiplied by 8 over 3, which is 8 over 9.
8 over 9. Great. I was expecting some kind of normal enough answer. Let's see. That's 8 over 9. I'm not going to labor this. I think you're good.
Okay.
You make y the subject and then you go from there.
Yeah.
Sure. Let me just see some. Yeah. All right. I think you're good. Let's continue.
Okay.
Okay. Differentiate again. Now you've got two terms. You just do each one separately.
Okay. So do I do 2x and then do 3x and then add them together?
What is the derivative of 3x?
What do you mean by derivative? Like the power?
The differentiate it, dy dx. So if you had y is equal to 3x,
Yeah.
what would be dy dx?
3x.
Uh,
3x to the power of 0.
Yeah. What is anything to the power of 0?
1,
Yeah.
which is 3.
3. The line y equals 3x. What's the gradient of that line?
It goes up 3.
Correct. Its gradient is 3. And so that's why it's not a function. It's just a constant 3, the whole thing. So that first one, if you have just x to the 1, it just gets rid of the x.
So would the other one be 2?
That would be the double derivative if you were to differentiate it twice.
Or would it stay as 2?
Yeah, it was x squared, so that's 2x. This was 3x, it's now 3.
Yeah.
Part B.
Yeah. Okay. So it'd be 16x minus 7.
The derivative of minus 7. If you have the line y equals minus 7, that's what it looks like. All the y coordinates are minus 7. What's the gradient of that line?
We don't know which direction it's going in though.
Doesn't matter. What's the gradient to this line? For every one right...
Minus 7. It goes up 7. Well, down 7.
Each time it goes one step to the right, how many up or down does it go?
It goes down 7. Oh, no, up 7 if it's going that way. If it's going from the bottom left to the top right of the graph. And it's going up 7.
That would it be if it looks like that.
Yeah.
That would be going up and down 7.
Yeah.
This one, how many up or down does it go for every change in x?
Minus 7.
No. One to the right, how many up or down did it go?
0.
Yes, its gradient is 0.
Yeah.
And so the derivative of any number is 0. And so that's like 16x plus 0.
Okay.
And now put the 3 together.
Okay. So you get 8x minus 3 plus 0. Or just, you'd have to pay anything. Yeah.
Yep, well done. Great. Good question, Bookie. Whoever wrote the book did a good one. That's it. Okay, how about this?
Okay. So would you need to substitute... Wait, no. You get the derivative of fx first.
Yeah, it's called f dash of x. So different names depending on if it's y or f of x.
Yeah.
Same
So
idea.
it'd be 8x minus 8. Is that all?
Yep.
And then we just substitute half into x.
Yeah.
Which gives you 4 minus 8.
Yeah.
Which is minus 4.
Well done. Part B.
Okay. So the last question we did, were we given the coordinates to work out the gradient?
Yeah. This time we're given the gradient and ask for the coordinate.
Okay. Would we need to work backwards?
Kind of, yeah.
So would x be 1?
Let me think. What is the equation you can make? So I see how this is saying the gradient is 8.
Yeah.
That is essentially the f dash of x is 8.
Okay.
What else is the f dash?
8 equals 8x minus 8.
Yes. So that's what you have to solve.
Okay. So can we plus 8 on both sides?
Yep.
Which gives you 8x equals 16.
Mm-hmm.
And then divide by 8 on both sides.
Yep.
So x is 2.
X is 2. Technically they said coordinates.
They want y.
Yep.
Oh.
Any idea?
So y is x.
Y is the f of x. When x is 2, what is y? Any idea how you do that?
Isn't it like the opposite, like minus? I don't.
The way we found the gradient when x was a half was we subbed a half into f dash of x.
Yeah.
Y equals the f of x, and so if we want the y coordinate when x is 2, we sub 2 into, instead of f dash of x, which would give us the gradient, into the f of x, the original.
Oh, okay.
So
it'd be 8 minus.
Hold on. What
So if
method?
you did 2 squared, which is 4 multiplied by 4, is 8 for the first part. 4x squared.
Hold on. 4 plus 4 is 8. 4 times 4?
16.
Yeah. Method mark. Wherever there's an x, replace it with a 2. And then you can do whatever you want after that.
So would you do indices first?
I'd put the whole thing in the calculator.
Okay.
Because there's no extra marks for...
There's not?
No.
Okay.
This is showing you're working. This is showing you're working out, essentially.
Okay.
Yes. And so that is 3. And so the coordinates of where the gradient is 8?
2, 3.
Well done. And so that is 2, 3. X is 2, y is 3. Great. I'll come back to part C later, I think.
Okay.
Let's see this one. All right. All right. How about this one?
Okay. You can't get the derivative.
Expand.
Okay. So it'll be 4 minus x squared.
4 and
Pardon?
minus 2x minus another 2x. No, you're right. It is exactly 4 minus x squared. Yep.
Yeah.
Okay.
And then can you substitute 5 in?
Yep.
X.
No. That'll give you the y coordinate. We want the gradient. So this is what y equals.
Oh yeah. So you so it'd become. Would you multiply 2 by x as well? Only by 4 when you're multiplying the coefficient by the power.
Just each one separately.
Okay, so it'd be 8 minus 2x.
No. Differentiate each one separately.
Oh. So would you do them as 4 squared and minus x squared?
No. What was the derivative of minus 7 in part B?